So looking at polyatomic ions, what are polyatomic ions? Let's first look at monatomic ions. The ions we've been working with so far, it's just one atom. Let's say chlorine, with its 7 valence electrons, needs one more, and it brings in an electron here to form the chloride ion. That would be the Lewis structure, or just Cl minus. That is the chloride ion. It is just one chlorine atom brought in an electron to fill its shell, and it's chloride. Oxygen, same thing. 6 valence electron brings in 2 to fill its shell, 2O2 minus. Just one oxygen atom has added electrons to fill its valence shell, and so we say it's a monatomic. It's just one atom has become an ion. Metals, same thing, ejecting electrons. Metal monatomic, just one sodium got rid of an electron to become Na+. Polyatomic means there are many atoms within the ion. So if it's a polyatomic ion, let's look at one of the most common examples. Here's oxygen. Of course, oxygen could fill its valence shell, say bring in 2 hydrogens to make H2O or water. Or it could do something like this. Bond with 1 hydrogen covalently. It's now got 7 valence electrons, needs one more. It could bring an electron from the outside to fill the shell, and it does. This is very common. Whoops. Put brackets around it to show it's a charged particle. So oxygen has filled that. It's got its 8. Hydrogen has its 2. There's a covalent bond between the oxygen and the hydrogen, but they add an electron so that it has a net negative charge. It is an ion. It is OH minus, which we call hydroxide. And so I've got 2 atoms covalently bonded together that added an electron to form a negative ion. Most polyatomic ions that we'll work with are negatively charged. There is only one NH4, that's 1 nitrogen and 4 hydrogens covalently bonded together that actually ejected 1 electron, and so it's positively charged. Most of them have added electrons. One really common polyatomic is nitrate. NO3 minus is nitrate. And I've attached a Google document that shows the common polyatomic ions that we'll be working with and you need to memorize. Nitrate. What is nitrate? 1 nitrogen and 3 oxygens that have added an electron to make their arrangement work. It actually looks like this. Let's not detail too much how I came up with this, but just look at it for now. We will, of course, later. 1 nitrogen covalently bonded to 3 different oxygens, but this arrangement, in order to make it work, they had to bring an electron from some sort of metal ion that was ready to donate an electron. So that would be called nitrate. 1 nitrogen and 3 oxygens covalently bonded together for nitrate. There are several different types of atoms. These are super, super common that do this. Another one, and let's not even draw the whole, sulfur and 4 oxygens. What with sulfur and 4 oxygens? They had to bring in 2 electrons to make this work. 1 sulfur, 4 oxygens that brought in 2 extra electrons to make that work. And this is one of our also super common. It's called sulfate. So those are, that's how polyatomic ions are. We will, of course, get into all the how to draw the Lewis structures in a later part, but for right now, let's work this for naming compounds. A polyatomic ion, more than 1 atom covalently bonded together that have added electrons, or there's only 1 that actually lost an electron, ammonium. In order to make everyone have their full shell, be surrounded by 8. Okay, let's look with naming and writing the formulas for ionic compounds that have polyatomic ions. Let's look at this one. Sodium nitrate. Sodium nitrate. Sodium, it's an ionic compound, right? So it's a metal with a non-metal polyatomic. Sodium is in the first column, Na+. Nitrate, on that list of ion names, NO3, 1 nitrogen, 3 oxygens, has a negative charge. All compounds are neutral. These combine 1 for 1. Now, with this, the naming rules are really the same as our other ionic compounds. 1 sodium combines for every 1 nitrate. NaNO3 is the formula for sodium nitrate. What about ammonium nitrate? So usually there's only one polyatomic ion that is positive, ammonium. So usually it's going to be a metal with some negative polyatomic, but ammonium's out there, it's fairly common. Ammonium on our list of ion names is 1 nitrogen and 4 hydrogens that actually eject an electron to make this work, right? So this is how it is. It actually lost a negative charge, so it's positively charged. And nitrate, NO3 minus. And again, this one, single plus, it's got a lot of atoms in there, but it's got a single plus charge. This one a single minus, so it just combines 1 for 1. The formula for ammonium nitrate, NH4, NO3. Now let's look at some different combinations. Calcium chlorate. So really important to look at these suffixes because there's a difference. Let me show you first. Calcium chloride. So you got to look at that suffix. The suffix says, oh, if it's IDE, that says, oh, it's just a monatomic. It's chlorine that has added an electron to form chloride. So IDE tells you, okay, that's monatomic. There's always exceptions. There's one polyatomic with the IDE ending, so you just have to remember this exception. OH minus is hydroxide. But for everything other than hydroxide, if you see IDE, that means it's just a monatomic. It's just that non-metal has added a negative electron or more. So it's just one, it's monatomic. Calcium Ca2+, I need 2 chlorines. We did this in the other video. CaCl2. Okay, so, but if it's not ide, what if it's 8? Or another one, ite, chlorate, or chlorite? That means it's a polyatomic. 8, all the 8s are polyatomics. It's 1 chlorine and 3 oxygens that have combined to have, that have added electron to make it work, and so it's ClO3 minus. Remember this L, so that's not carbon, iodine, oxygen. I always write the L's just like this. If it's an iodine, I put it like that. So chlorate, calcium's 2+. Same thing, all compounds are neutral. So in order for this to work, this is 2+. This little group here is single minus. I need 2 chlorates. Now, when I have more than one polyatomic ion in my formula, I put the parentheses, so I don't want to change it to this, like Cl2O6. That would be incorrect. Right? So what I want to show is that's a polyatomic in there, in this formula. I've got chlorate. How many do I need? I need 2 chlorates for every calcium in order to make it neutral. So I put parentheses. The only time to put parentheses is if you have more than one polyatomic ion. Let me show you examples. So that would be the formula for calcium chlorate. Sodium carbonate. We're going to do just a few more examples to show you how these rules work. Sodium is Na+, carbonate, CO3, 2 minus. So this little group of atoms has added 2 electrons. It has a 2 negative charge. For each group, there's a 2 negative charge. Sodium has only a single plus. In order to make it neutral, I need 2 sodiums. What does that look like? Na2CO3. Notice there's no parentheses in this because I don't parentheses around a single atom. There's two of that. I only have one carbonate, so I don't put parentheses around that. So if there's just one polyatomic, no parentheses. That would be the formula for sodium carbonate. Ammonium. And let's make this ammonium sulfate. What is ammonium? It's NH4. What is sulfate? It's 1 sulfur, 4 oxygens that have added 2 electrons. This little group polyatomic ion has added 2 electrons. That has a 2 negative charge. This has lost 1. Single minus. What do I need? I need 2 of these. For every sulfate, I need 2 ammoniums to make this compound neutral. NH4 parentheses 2 SO4. Ammonium sulfate, that's the formula. I put parentheses because I have two ammoniums. No parentheses here because there's just 1 sulfate. All right, I want to do 2 more examples with you to finish this video off. And let's do this one. Get some transition metals in there. Copper 1 phosphate. Copper, remember the Roman numeral 1 means that copper has a single plus charge. Phosphate, 1 phosphorus and 4 oxygens have combined. They had to add 3 electrons to make this one work, so it has a 3 minus charge. Cu plus, Cu plus. I need 3 coppers for every phosphate, and Cu. All right, let's do one more. Almost lost you. Let's do one more in reverse. What's the name of that compound? I see CO3. CO3 is carbonate. I see that I've got 3 carbonates. Let's write them out. And I see I've got 2 irons. Iron is a transition metal, so I don't know what the charge of iron is. I need to use the nonmetal, or in this case the polyatomics, to figure out what the charge of iron is. Each carbonate has a -2 charge. 2, -4, -6. Has a -6 total. Therefore, I need a +6 total. So what is the charge of iron? 2 irons make +6. They're each +3. Right? So each iron is a +3. Iron, 1, 2, 3, carbonate. All right, and then let's practice our naming of ionic compounds using transition metals.